Let us look at this question on series. We are asked to find the sum from 1 to infinity of this series. Okay? Now, the first term of this series is A, we call it A, is when R has the value 1. So it is 15 into 1 quarter to the power 1, which is 15 all over 4. Our second term, so this is your T1, which we call A. Our second term, T2, is when R has the value 2. So 15 into 1 all over 4 squared. This is going to give us 15 all over 16. Okay? So, our third term is when R has the value 3. So, we are going to have 15 all over 4 to the power 3. We have 64. Okay? All right, so our series can be written as of 15, 1 all over 4 to the R can be written as 15 all over 4 plus 15 all over 16 plus 15 all over 64 and so on, right to infinity. And so we see that our common ratio will be T2 all over T1. Okay, T2 is the second term. This is our T2, 15 all over 16 divided by T1, 15 all over 4. This is 15 all over 16 multiplied to 4 all over 15. And so we see that 15 here cancels, 4 here 1, 4 there 4. And so we have 1 quarter. All right, so our common ratio is 1 quarter. All right. This sum of our Tn, our general term, is actually what we call sum to infinity. All right? And sum to infinity for a geometric progression, because it's only a geometric progression that has common ratio. All right? The sum to infinity is usually the first term all over 1 minus the common ratio. All right. So we know our first term, which is 15 all over 4, and we know the common ratio 1 all over 4. So let's apply that formula. All right. We know our first term, 15 all over 4, and we know our common ratio 1 all over 4. And we know sum to infinity, all right, is A all over 1 minus R. So it is 15 all over 4 divided by 1 minus 1 all over 4. Okay? Divided by 1 minus 1 all over 4. This is 15 all over 4 divided by 3 quarter. This is 15 all over 4 multiplied to 4 all over 3, which is 5. So the sum to infinity or this expression gives us 5.